Assalamualaikum everyone. So we are going to start a topic today that is called homogeneity of equation. So let's begin with the definition, how we can define this thing. An equation is homogeneous if each term has the same base unit. Okay, this topic is more close to the mathematics, and we are going to use our knowledge of base and drive unit in this thing. Let's suppose if there is some term x is equals to ab plus cd plus ef. So this x, this ab, this cd, this ef, they are considered as a term. This ab is a single term, right? So this term, this term, this term, and this term, if they all have the same units, they will be considered as homogeneous. Okay, so let's try one example. Let's suppose we have some equation and we have to prove that this equation is homogeneous. Let's take example of kinetic energy. We know that kinetic energy is 1 over 2 mv square. This equation is given to you and you have to prove that this is homogeneous equation. Okay, so how we can prove that? We know that energy provided is equals to work done most of the time, right? So this thing can be written as work done, and we know that work is equals to 4 times displacement, so it can be written as ft and half mv square, right? So now let's use the unit analysis. So units of f, how it can be written? F is equals to ma. So for m it is kg, for a it is meter per second square, so it will be kg meter per second square. Okay, for d it's the distance, it is the meters. Okay, and 2 does not have any unit because it's simply a number. For m it is kg, and for v it will be m as -1, and there is a square on it. So if you see, just let's simplify this thing. It will be kg, there is 1 meter here, 1 meter here, it will be meter square per second square, and on the right side kg, when you open this square, it will be meter square per second square. So if you see this thing, they both are exactly equal, so we can say that this is this is homogeneous equation. Okay, so let's discuss another example. S is equals to ut plus half 80 square. Let's suppose this is some formula that we have to prove that it is homogeneous. So S is what? S is the distance or displacement. Both have the same unit, so it does not matter. U is velocity, initial velocity. Okay, and v is final velocity, and a is acceleration, and t is time. So let's begin. S is the displacement, so it is meters, and as we have discussed, this whole thing is a single term, right? So this thing, for the u it is meter per second, and for the t it is second, and this will not have any units because it's simply a number. For a it is meter per second square, and for there is a t square, so it is a second square. Okay, let's simplify. It will be m as -1, and this is s power plus 1 is equals to ms minus 2 s power 2. So when you simplify this thing, these will be cancelled out, these will be cancelled out with each other, so it will be m is m plus m. So if you see, all these three terms are same, right? So this is homogeneous. Okay, let's discuss another example. Let's equation is s is equals v is equals to u square plus 2as. V is final velocity, u is initial velocity, a is acceleration, s is displacement. Okay, so let's begin. V is meter per second and there is a whole square. Okay, u is meter per second, there is a whole square, plus 2 will not have any unit. For a it is m as minus 2 and for it is m. Okay, let's simplify this thing. When you open the square, it will m square minus s square, m square s minus 2 plus m square s minus 2. So if you see, this is equal, but this is not equal, so this is non-homogeneous. Okay, so this is how we can prove that whether the equation is homogeneous or not. Any formula that is not homogeneous will not be a correct formula or a correct equation. Okay, so for the relationship to be correct and applicable, it should be homogeneous. Okay, so we will continue this thing in the next lecture and we will discuss how we can use the homogeneity to solve our different problems.